Okay, good morning, ladies and gentlemen. The date for today is December 20, 2023, and the time is 12:09 a.m. Okay, my topic for this session will be a long video format discussion, and the topic is still on AC machines. We are almost done with AC machines, okay? And the lesson for this morning will be AC machines, lesson number 67. This is a very interesting topic. It's the so-called parallel operation of alternators. These are the connections made by utility companies to supply us power. Their alternators are actually operated in parallel because if you try to operate it singly, okay, there come a time that that alternator might be damaged. So it's a must that they should operate alternators in parallel for the so-called the importance of the so-called continuity of service. Okay, let's proceed. The subject matter for this morning will be a long video format, and this is on AC machines, and we are now on lesson number 67. Okay, and the title of the topic will be Parallel Operation of Alternators. For this morning, we do not have any calculation or formula derivations. So what we will be discussing is how are alternators operated in parallel, and what are the requirements before we can operate alternators in parallel. Okay, let's proceed. For modern power plants, actually, they operate alternators singly, meaning single operation. Uh, if we see single operation, it could be that the alternator being mentioned is actually a very big one, maybe the what they call this the total apparent power that could be delivered by that alternator will be in the so-called million volt amperes, MVA. Okay, so singly, it could be that the total apparent power by the alternator is in terms of MVA. It's not only kVA. kVA is a 1000 volt ampere, but capital letter M, then a VA will be a million volt ampere. So this is a very big one. So meaning to say, if the alternator is very big, okay, you could operate it in the so-called single operation or operates singly. Okay? But if the alternator is still rated MVA but not as high as the first one, we could operate them in the operations, the so-called several parallel combinations. Okay? So meaning to say, if the ratings now will be an MVA, but this one is smaller than this, the big one could be operated in single operation. But if there are two alternators in which the apparent power is less than the big one, we could operate two alternators, okay, with an MVA rating, but it is less than this, so we could connect them in the so-called parallel combination. Okay, so at least we now know when to operate alternators in parallel. Like if you got a 1000 MVA alternator, that's a very big one. Or we could have a 500 MVA, right? So to satisfy this 1000 kVA, if we try to operate the alternators in parallel, we will be needing a two alternators which is rated 500 MVA. So you see the option now. You could operate a 1000 MVA big alternator in single operation, or you could operate two alternators in parallel, okay, and which the rating of each will be 500. So the 500 times 2 will still be equal to 1000. It will still satisfy uh, the load that is connected to the bus bar. Okay. What are the reasons why we operate alternators in parallel? Actually, it's only two. The operation will be cheaper, so it's economy, okay? And the so-called continuity of operation. If the alternators are connected in parallel, okay, this continuity of operation is actually very high, right? Why it's very high? Because there are two here, and the single operation is just only one. So for the single operated alternator, okay, if it got what you call this damage, or there should be a problem with it physically, you cannot do anything, okay, to operate it. So you must have to shut it down. So there will be a problem with the so-called continuity of operation now. But if there are two alternators in parallel, if the other one got a problem, we could disconnect that other one, okay, and we will still deliver power to the bus bar going to the customers, but it should be with the so-called lesser load. That's why sometimes if one alternator got the what problem, they will try to disconnect that one, right? But the other one will still operate, but at a lesser load. That's why sometimes, okay, there are brownouts going to our houses because they will try to rotate the power distribution of that available power from that single operated alternator if the other one is actually damaged, or it got a problem. So for the reasons for the so-called parallel operation, it should be cheaper, and the continuity of operation, okay, at least we are sure that the continuity of operation will be very high. Okay? Much more if the number of alternators connected in parallel is 3, right? If the other one got a problem, you got still 2. They could still deliver power, but it should be at a lesser load. Okay? That's the problem of the so-called distribution engineers now. They will try to disconnect some loads, okay? Because if they will not try to disconnect some loads, so the alternators will be what they call this overloaded. That's why sometimes during peak operation, our air conditioning units should be shut off. We do not have to operate them at the same time because they consume too much power. So if there are 3 and the other one is got a problem, you could operate 2. But to operate these 2 here, you must have to disconnect some loads in the distribution circuit to satisfy the total power delivered by these 2. You must have to subtract some loads, meaning to say you must have to brown out some houses, okay, because you could not satisfy their power requirement because one alternator might be defective. So that's the main reason for the so-called parallel operation of alternators. So at least we are expecting a very high continuity of operation if there are more alternators connected in parallel. Okay, so at least we now know that if we try to operate alternators in parallel, okay, the continuity of operation will be very high. Okay, let's try to bring out the requirements in which we just assume for the meantime that we are connecting one alternator with respect to another one. So meaning to say, we got now a first alternator supplying this line number 1, line number 2, and line number 3. And if we try to connect a second alternator, okay, And parallel with alternator number 1, this should be the connection. And there must be a requirement before we could connect a second alternator to the bus bar. Bus bar meaning line number 1 and line number 2 going to the step-up transformer. So assuming this alternator is running now, and we would like to connect a second alternator, okay, to help alternator number 1 deliver current to line number 1, line number 2, which is going up to the step-up transformer. There are some requirements needed for it to be, meaning to say the operation should be smooth. And the requirements are these. We got 3. If on the study of transformer, before we could connect transformer and parallel, there are some requirements before we could connect them. So they will not try to produce a circulating current on the circuit if there is no load connected. And the number 1 requirement is that the voltage of the incoming alternator, if this is the connected alternator and this is the incoming alternator, the first requirement is that the voltage of the incoming alternator should be the same as the voltage of the alternator that is already connected to the bus bar. Meaning to say, if you try to measure the voltage here, okay, this is the alternator which is already connected to the bus bar. The voltage of the incoming alternator, okay, considering line number 1 and number 2, if the voltage of this is 2300, the voltage of the alternator, the incoming alternator, line to line, it should also be 2300. Okay? It's not that you could not operate it correct. The operation should not be smooth if this is 2300 and this is 2500. There is a problem with that one. We got a problem with the so-called circulating current. So it's a must that the voltage across here should be equal to the voltage across here. For all the 3 phases, meaning line number 1, number 2, line number 2, number 3, and line number 1, number 3, should all be the same for both the alternator that is connected with respect to the incoming alternator. So that's the first requirement. The voltage reading, line to line, should be the same. Okay? If this is B, this should also be B. Right? The voltage across this should be equal to the voltage across this. And that's the first requirement. Same voltage rating. The next requirement is the frequency of the incoming alternator should be the same as the frequency of the alternator that is already connected to the bus bar. Meaning to say, if alternator number 1 produces a 60 Hz sine wave, the frequency of the incoming alternator should also be 60 Hz sine wave. If this is 60 Hz, this should also be 60 Hz. You cannot connect an incoming alternator if the frequency is 60 Hz. If the frequency of the first alternator is 60 Hz and the second alternator has a frequency of 50 Hz, there will be a problem on the so-called wave. Right? If this is 60, 50 will be different. It will be smaller. Right? So when we try to connect what they call this our electronic equipment which needs a sinusoidal voltage as the input, okay, if this is 60 and this is 50, there will be a problem. The average will not be equal to 60. So if your laptop is what they call this needing a frequency on the primary of 60 Hz and this is 60 Hz and this is 50 Hz, there will be a problem. So it's a must that if this is 60 Hz, the frequency of the alternator number 1 is 60, the frequency of the incoming alternator should also be 60 Hz. They should be the same. They should not fight out with the frequency. Okay? If the first one is 60, the second one should also be 60. Okay? And the third condition is same phase sequence. Same phase sequence. For the phase sequence, we could, what do you call this, explain this one by seeing our figure. Alternator is actually connected, it's always a Y, a Y connected. So for the phase sequence, for us to satisfy the phase sequence, if this point here is A, and this point here is B, and this point here is C, A should be connected to line 1, and C should be connected to line 2, and B should be connected to line 3. Okay? For the incoming alternator, for its phase sequence to be the same as the first one, we just follow the markings. So this should also be A, and it should be connected to line number 1, and this should be terminal B, and it should be connected to line number 3, right? And if this is terminal C, it should be connected to line number 2. So if we follow the markings of alternator number 1, and the incoming alternator follow that designation, we could say that their phase sequence is the same. Okay, that's phase sequence. I think, guys, that's it. Those are just the requirements for us to operate two alternators. For this diagram, we are just considering two alternators. Okay, we are just comparing, but in actual, we could operate three alternators, four alternators, but for simplicity of the so-called explanation, we just place here alternator number 1 and number 2. Alternator number 1 is the one now supplying this transmission line, and we should connect second alternator number 2 to this transmission line going to the step-up transformer. Okay. So the requirements is that, I will repeat it before we will go for this morning. The voltage rating should be the same. Okay. The frequency should be the same, meaning if this is 60 Hz, the frequency produced, the generated voltage of the alternator number 2 should also produce a 60 Hz frequency. And the third requirement is that the phase sequence should be the same. For the phase sequence to be the same, we should just follow the markings of alternator number 1. Okay, if we try to connect it to the feeder lines, right? So if A should be connected to line number 1, A should be connected to line number 1, B should be connected to line number 3, B should be connected to line number 3, and C should be connected to the line number 2, and C should be connected to line number 2. We could say that their phase sequence is the same. Okay? Okay, that's it, guys. At least we now know how to operate alternators in parallel. What are the requirements for the operation of the alternators to be what you call this, they should operate without producing a circulating current when there is no load on the feeder lines. Because the problem here, if the voltages are different, like in the transformer, there should be a big circulating current, and that's a wastage of power, right? And we might burn some of the armature windings. So it's a must that we should follow these three requirements. Same voltage rating, same frequency, and same phase sequence. Okay, that's it, guys. Good morning from Los Angeles. This is Professor David J.